Section 3.2 Measures of Center. One way to describe a data set is by its center value. This value can be calculated in many different ways. We will take a look at the mean, median, mode, and mid-range as measures of center. Example 1. Compute the mean, median, and mode of this data. So we have this data set, 15.2 as our first value, 9.3, and so on down to 8.3. And first we're asked to find the mean. The mean is found by summing all of the data values and dividing by the total number of data values. So if I were just going to sum up my values, I could start putting that into my calculator, 15.2 plus 9.3 plus 7.6 all the way down to 8.3, and I get a sum of the x values, my data values, of 139.3 divided by lowercase n. So this sum of x, summation x, means add up all the data values, divided by lowercase n is the number of data values in the sample. If it were a capital N, that would be in the population. So we know we're dealing with a sample. And we have 12 values in our sample. So if I take that total and divide by 12, we get 11 point, now I'm going to round to the second place after the decimal, 11.61 for our mean. And I just wanted to make a note about rounding. It didn't happen in this problem, but when you have an intermediate step, make sure you don't round until the very end. So here we had 139.3, and it actually was exact. We didn't have any other digits behind the 3, like 139.35728. But if we did, you wouldn't want to round to just 139.3. You'd want to keep as many decimal places. Let your calculator handle that, and still do your calculations. So for us, meaning divide by 12, and don't round until the very, very end. If you do happen to round beforehand, you can really decrease the accuracy of your final answer. Okay, next, before we get to the median, just wanted to mention something about notation when we're dealing with populations and samples. So depending whether the data comes from a population or sample, the notation for the mean can change. If the mean is calculated from a population, this is expressed as mu, so this lowercase Greek letter, mu. And if it's calculated from a sample, it's expressed as x bar, so that bar across the top. Remember, calculations from a population are called parameters, P for population, P for parameters, and calculations from a sample are called statistics, S for sample, S for statistics. Pretty much for a lot of other calculations that we'll do later on, Greek letters are used for population and regular letters are used for samples. Okay, let's go ahead and find the median. Now the median is found by ordering all of the data values and finding the middle value. Whether you go in ascending order or descending order doesn't matter as long as you put all the values in order. So looking back up at our data set, it looks like, and I'm going to go in ascending order, it looks like our first value is 7.6, and then we have 8.3 next, then 9.3, and a few more values here, and then 11.5, 11.9, 15.2, 16.2, and finally 20.4. So after I put all the data values in order, the median is the value that's sitting right in the middle. Well, if you look at our data set, we had 12 data values, which is an even number. That means there's not a value sitting right in the middle. So if you have an even amount of data values, you're going to take the average of the two middle values. So since there's 12 data values, that means we're going to look at the 6th and 7th data value. So that for us will be these two values, 9.7 and 10.4. So we'll average those two together, 9.7 plus 10.4 divided by 2. So we get 20.1 divided by 2, which should be 10.05. So the median, which this value is right in between, halfway in between 9.7 and 10.4, is 10.05. Finally, the mode is the data value that occurs most often. So we're looking for a value that repeats, and if there's more than one value that repeats, we want the one that repeats the most often. In our data set, it looks like the only repeating value was 9.4. So our mode is 9.4. Real quickly, if you're using the TI-8485, I want to show you some features on your calculator that can make calculating these statistics or parameters a lot faster. So if we go back up to our original data set, on my calculator I'm going to put this button Stat. I'm going to stay on Edit, the menu Edit, and the first option is Edit. What this is going to allow me to do is put in a list of my data values. Now if you have a list that already has some values in it, if you highlight the list name, so L1, and press Clear, and then arrow back down, it'll clear out the list for you. So I'm just going to type in what I have here, 15.2, 9.3, 7.6, 9.4, and 8.3. Okay, so I have all my data values in. So we found the mean by adding up all the values, typing all that in, summing divided by 12. Well, here's something we can do to find the mean and the median kind of all in one step. So once we get our list in, go back to Stat, and this time use your right arrow button to arrow over to Calc, and notice the menu changes. And the very first option, 1 var stats, or 1 variable statistics, select that by pressing Enter. And what I have to do is tell my calculator which list to run 1 variable statistics on. And we put our data in list 1, and here's that little notation, that L1 right here. So I'm going to press second and the number 1 to get to L1, and then press Enter, and the calculator gives me a bunch of statistics back. So if you notice here, we have X bar 11.608. Well, that's what we got previously. Also, the median, this arrow here means there's more information, use your down arrow and arrow down. MED stands for median, 10.05, which is exactly what we got. Now you're on your own for mode, but I just wanted to let you know that. Oh, one other feature, go back to Stat. Remember, we had to go through and order our data for the median. Now, although the calculator can find the median for us, once it was in order, it made it pretty easy to figure out what the mode was because the repeating values are going to be right next to each other. Well, your calculator can do that also. So I press Stat, I'm still on that Edit menu, but if I go down to number 2, Sort A, which stands for Sort Ascending, and press Enter, again, I have to tell my calculator which list to assort, or to sort, ascending rather. So press second L1, because that's where my data is. Press Enter, and you'll get a message that just says Done. The list is still where it was, but now it's sorted. So to look at it, I press Stat again, go back into Edit, and now my list is sorted in ascending order. And it makes it really easy to look and see, oh, there's a repeating value, 9.4. So we'll use that technique as we do some of the other problems here in our notes. Example 2. A small company consists of the owner, the manager, the salesperson, and 2 technicians, all of whose annual salaries are listed below. And we're going to assume that this is the population. Part A, compute the mean, median, and mode of all the salaries. Now it's completely up to you how you prefer to do this. You can still do it by adding up and dividing or using the formulas, but I'm going to go ahead and use the Stat feature in my calculator. So I press Stat, Edit, and I'll put my information in list 2 this time. So we have 60,000, 30,000, 22,000, and 19,000 twice. Okay, so I want the mean and the median. That's going to, my calculator is going to give that to me really fast. So if I go to Stat, arrow over to Calc, one there's Stats, and this time my data is in list 2. And we get that X bar is 30,000. And the median, so I have to arrow down for that, is 22,000. Okay, and that might have been easy to find just looking at our chart since we only have 5 values. And for the mode, again, we can just look at our little table here. Well, 19,000 is the only value that repeats, so that's our mode. Be careful with the one variable statistics. If you don't get all your data values entered, or if you make an error entering them, you won't know that when you get the statistics back. So just be really careful with that. You might double check yourself sometimes doing it manually, but use a little bit of, common sense. Double check, make sure the mean is not way far out, unrelated to your data values. Okay, example B, or part B rather. The owner has decided to increase his salary by 50%. Compute the mean, median, and mode with this new salary, and determine which measures of center are affected by this change. Well, if he increases his salary by 50%, that means we're going to take 60,000 and multiply it by 1.5. So his new salary will be $90,000. So we're going to do all the same statistics and see if or what, if anything, changes. So I'm going to go back into my list, and I'm just going to write over that 60,000 and replace it with 90,000. And I'm going to run my one variable statistics again and see if anything changes. Well, it looks like the mean definitely changed. This time X bar is 36,000. But the median is still 22,000. And the mode is still the one that repeats, so that's 19,000. So it looks like the mean was the only one affected by the owner's new salary. So because median depends on position, we didn't add another data values to the set, we just changed one. The median didn't change, and the same thing for the mode. Part C. To be included in a report of average salaries for workers, the owner is asked to exclude his salary from calculations. Calculate the mean, median, and mode for just the workers' salaries. So this time we are changing the number of data values we have. So I'm going to go back into Stat, go back to my list, and I'm going to delete that first data value. So if I just hit delete, it's gone, and now I'm down to 4 values, and I'll run my Stat, one variable Stat again. Okay, so the mean is 22,500. And if I arrow down, the median is 20,500. And the mode, which is still the one that repeats the most often, is 19,000. Okay, so we saw 2 changes this time. We saw the mean change, so we threw out that really high value, that 90,000, and our mean went way, way down. It's probably more representative of the worker's salary now without the owner's salary being thrown in there. But the other thing that changed was the median. Well, if you think about it, we had 5 numbers, and when we pulled one away, now we only have 4. And kind of like with our previous example, when we only have 4 data values, to find the median, we had to take the average of the 2 middle values. So looking back at our chart, that means we got rid of this one, and we have to find the average in between 22,000 and 19,000. So that's where that 20,500 is coming from. But there wasn't a value that was neither of those changes affected the mode. Okay, finally part D. An additional salesperson will be hired with the same salary. How does this affect the mode? Well, now, if we hire another salesperson, now we have the 60,000, but we are also adding another 22,000. Well, now 19,000 is not the only value that's repeated. And depending on some interpretations, this is what happens with the mode. One option is to say, now that 22,000 repeats as often as 19,000, there is no mode. So there isn't one value that stands out as the one that has the most repeats. Another interpretation, though, sometimes will say that this is bimodal, meaning I have 2 modes. So depends sort of sometimes on the textbook. For us, we'll just say that it's no mode. So if I have 2 values that repeat the same amount of time, then we'll just say that that's no mode. Okay, mid-range. Mid-range is the value halfway midway between the smallest value and the largest value. To find the mid-range, sum the smallest value and largest value and divide by 2. So back to our salary data from the small company in example 2, we're going to find the mid-range of all the salaries. Well, remember the highest salary was the owner, and originally his salary was $60,000, and the lowest salary was a technician, technician 2, at $19,000. So to find the mid-range, I'd add those 2 together and divide by 2. That's a total of 79,000, and we divide by 2. So we get a mid-range of 39,500. That's it to the mid-range. Okay, here's another, something a little bit different, but it still has to do with the mean. Example 4. Suppose a student who took 4 classes last semester tells her parents that she earned 2 A's, a B, and a C. Knowing that an A is worth 4 points, a B 3 points, a C 2 points, and a D 1 point, her parents quickly determined that her semester GPA is 3.25. Upon more careful inspection, however, the credits per class are as follows. So she kind of didn't let them know everything that was going on. So they just thought, oh, 2 A's, a B, and a C, and they went ahead and did this. They did 4 plus 4 plus 3 for that B plus 2 for the C and divided by 4 grades. So they got 13 divided by 4 for 3.25. But let's take a look at her coursework. So for English composition, well, that class was worth 3 credits. College algebra was also worth 3 credits, but biology was worth 4 credits. That's where she got the C. And body conditioning was only worth 2 credits. So in this case, instead of just adding up the points for the letter grades, we have to do something a little different. So each class is worth a different amount of credits, and it's not accurate just to calculate her GPA by just finding the mean of the letter grades. This is where a weighted mean is needed. So it's still the same notation, x bar, but it's just calculated in a slightly different way. The formula is to take the frequency times the value, the data value, and divide by the sum of the frequency. So we're going to add up each frequency times its value and then divide by the sum of the values. So to find the weighted mean, that's here, we multiply each letter grade point value by its respective credit and then sum those products and divide by the total number of credits. So English composition was 3 credits and multiply that by 2 since she got a B. And then 3 credits for college algebra and multiply that by 4 since she got an A. 4 credits for biology but multiply that by 1 for the C. And then 2 credits for body conditioning and multiply that by 4 for the A. But we're not going to divide by 4 just the number of classes. We're going to divide by the total number of credits. The total number of credits is the 3 plus 3 plus 4 plus 2. So we end up with 6 plus 12 plus 4 plus 8 divided by 12, which works out to 2.5. Well, that's quite a bit different from 3.25, which is how the parents calculated her grade point average before. So if you have a weighted mean, and this is usually going to be used when you have a frequency distribution or a frequency table and you don't have the original data values, but you know that there were so many values in the first class and so many values in the second class and something like that, this is how you would calculate it. But just to illustrate that, finding the mean one way, if you have some weighted values, is not accurate. So when we did it the correct way, we find that her GPA is really a 2.5. Finally, I just wanted to mention something about the shape of our data. So depending upon whether many values in the data set are small, large, or both small and large, we'll get a distinct shape or skewness to our data. Look at the following examples. Example 5. Determine the skewness of each distribution and discuss the position of the mean, median, and mode. So example A, this graph displays the number of children by U.S. presidents through Barack Obama. So if you notice, for most U.S. presidents, they have between, so here between 0 and 2 would be, 0 to 1. Here this bar would represent 2 or 3 and so on. So most presidents probably have 1, 2, or 3 children. And notice that it's quite rare for someone to have 8 or more children. So this distribution, if you think of kind of superimposing a curve over it, this is considered skewed to the right. So always think of the skewness in the tail. This is skewed to the right. So what happens here is, now the mode is pretty easy. The mode is whatever the one that's the most. So that's right here. That would be the mode. What happens is, because of these very large values, it pulls the mean a little bit with it. So the mean is kind of, it's close by, but it's pulled out a little bit. And the median is here also, but it's also pulled a little bit to the right. So because we have these values that don't occur very often, but they represent big numbers, we get this skewness, and it pulls the mean and the median with it a little bit. Okay, example B. This graph displays the graduation rates as a percentage for each state in the U.S. Well, looking at this one, notice that our trend is a little bit different. We have it skewed to the left. So it's not, the skewness is not quite as extreme perhaps, but definitely we see these smaller values going off to the left. Again, our mode is whichever one is the highest right here. That's our mode. But our mean is going to be pulled a little bit to the left because of the smaller values, and the same thing for the median. Now it's best usually to calculate these from scratch, but just want to show you kind of a trend of what happens whether we're skewed to the left or skewed to the right. And finally, this graph displays the number of pups born in a lifetime by each of 80 great white shark females. This data is rather symmetric. It might not be perfectly symmetric, but it's roughly symmetric. How it looks on the left is almost the same as how it looks on the right. When you have symmetric data, the mean, median, and mode are just about all right there together. They're roughly, if it's perfectly symmetric, they'd be exactly the same, but the more symmetric it is, the closer they are together. So just keep in mind, skewness is in the tail. If I have a lot of values going on to the right, then it's skewed to the right. If I have values going off to the left, it's skewed to the left. But if both sides look relatively the same, then we consider that roughly symmetric.